Now, though there were many different programming paradigms that we have read about and we've actually used for several years now, most of it, I think, kind of originated with procedural programming. This is back when applications were developed by calling upon functions in a certain order or taking certain steps in order to complete a given task. Now, there were several problems with this paradigm, of course. Number one, there was no reuse outside of the application, and it was also very linear. There was no real analogy to the real world or to the process that it was trying to solve or the tasks that it was trying to solve. This is where the next evolution came in, and this was what we call object-oriented programming. This was procedural programming to the next level. Now we separated our application into parts or objects that resembled real-world entities that represented the task that we were trying to solve. You can actually break this down into something like nouns and verbs, where you got objects, which are your nouns and properties, and of course the verbs, which are the methods. Objects housed both data and behavior, of course, and they had a nice correlation to the real world counterparts or the problem, the business problem that we were trying to develop for or solve. Now, once again, this had a share of shortcomings, and of course, once again, we couldn't reuse outside of an application. There was no real plumbing that allowed us to use objects from one application to the other without doing traditional copy and paste. This is where component-oriented programming came in. The next step basically took object-oriented to the next level and provided a common abstraction layer. We see this as COM, for example, or COM's competitors. And we can now use objects across technologies, across different platforms, because of these abstraction layers that provide the coupledness between the objects. Another drawback that component-oriented programming had, as well as the previous paradigms, is that you were essentially exposing everything to the client. So once you solve the problem of getting components to talk to one another or the client to be able to access components in different libraries, the client could see everything. And that might not be ideal in my opinion, in most situations. So this is what evolved into service-oriented programming. Service-oriented programming took the previous programming paradigms and abstracted them behind what we call a service wall. So we still use objects, we still use components. Even inside the objects, we may use some procedural style programming. We can use other paradigms like functional programming, etc. But what's exposed to the outside world is a lot more restricted and a lot more secure. Things are better managed and things are more encapsulated into what we refer to as services. Now, some drawbacks still exist, but these are more technology based. We still needed a good glue technology to handle a lot of the cumbersome plumbing that we needed to take care of inside services, to make sure that they're transactional, to make sure that they're secure, all sorts of different characteristics that I'll discuss in just a few minutes. This is where the technology came into play. This is where WCF and now the Web API come into play.